we all know that we discussed that it is a layered architecture and we have 7 layers in this. Okay, physical layer, data link layer, network layer, transport layer. Okay, then session layer, presentation, and application layer. These are the 5 layers at each node. So this is node 1, this is computer 1, and this is node 2. Okay, so here we have discussed about yesterday we discussed the physical layer and the data link layer. Okay, and we have discussed the characteristics and the function of those layers. So now, as we all know now that at this data link layer, the device which we use is that is switch. We all know we use switch here. Why switch? Because switch is switch can read MAC addresses, and data link layer is responsible to send data to the destination or to the receiver node within the network. Within the network, that's the main key. And within the network, switch is capable enough to read MAC addresses, that is physical or hardware address of each and every node. So switch knows which node is there. Okay, and to whom we have to send that data. So at this layer, data link layer, we use switch, but the data which we transmit, that is called data frame. That is called data frame. Okay, or frames easily we can say. Now the network layer. Now what are the responsibilities of network layer? What it does, whenever we are sending a data packet outside the network, okay, when the destination node is outside the network, at that time network layer is responsible to send that packet. And that is why in data link layer it was termed as data frame. Here it is termed as data packet. And to transmit data outside the network, we use which device? As we discussed earlier, we use router, because router is the only device which can, through which two different networks they can communicate, or to connect to different networks we need a router in between. Okay, so at this layer we need a router. Okay, and the data, they are in the form of data packets. Now it is termed as a packet. Okay, so can you see the difference? Here it is called data frame and it is a data packet here. Switch was used at data link layer within the network if we are going to transmit some data, and if we are sending data outside the network, then router will be used. Now network layer, as we can see here, it uses logical addressing. Now what is that logical addressing? We have already discussed that in logical address we use IP address, Internet Protocol address. That is our logical address. And in data link layer, which address we use? MAC address. Now we can easily, identify that this is MAC address. So MAC address, which device knows or reads MAC address? Switch. So that is why it will be used here. Now, which device can understand IP address? Router. So that is why router will be used at network layer. Now you're getting why we have discussed the routers, the devices part first. If you remember, see, this is the OSI model, and we discussed devices and tools. Okay, networking devices. Why? Because these devices, now we are knowing that how these devices are used at different layers of the OSI model. Okay, so router will be used here. So sorry, this network layer, it uses logical addressing, that is IP addresses. We'll discuss right now. I'll tell you with the diagram, with the help of a diagram. Now the second thing is routing. network layer does routing. Routing means, let us suppose, let us suppose you you want to go to, if I take example of Dehradun city only, if from university you want to go to Ghantaghar. Now there are multiple ways, multiple options. Okay. Now you usually use the road through railway station, but today you came to know that there is too much traffic jam or congestion is there. So what you will do, you will follow some different route, isn't it? You will follow some different route. Might be you will go through Ballupur or Balliwala, Chakrata road. Okay, so you will use some different route. So at the time of these congestions and all, you try to find out the shortest path. Along with that shortest path, there are some other matrices as well. Okay, so you will see where is the load, higher load, and where which path or which route is having less load, and the bandwidth as well, and the how much congestion is there. So you have to define a route through which route you will reach to the destination. In the same way, at this level, at this layer, network layer, as we use router, it is named router because it defines route. It finds out the best suitable route, best suitable path to the destinations. Because there are so many networks in the world, in the globe, and all the networks, they must be having one router, because without router they cannot connect to the internet or to the other network. The router is imperative, mandatory here. So that is why what router does, router shares its routing table. Actually router keeps track of it, creates a table that what my neighbor router is having, which the neighbor router table, it is also maintaining a routing table, and it maintains that to who other routers, what are those routers through to them which that router 2 is connected. So they will, router 2 will share that routing table to the router 1. So in this way they share their table to all the adjacent routers, their neighbors, what are their neighbor routers and what they carry on their table. So they, you know, they share those tables. So using those tables, routers define that what will be the shortest path or what will be the best path. Okay, let us suppose you send something, you send a mail. Now you send a mail, but your server is you send a mail through Gmail. Okay, but Gmail server, let us suppose, is in USA. So you have, your mail will go to server first. Now let us suppose the routers, they are connected in such a way. Okay, our network from India, our router from India, it is going through the Middle East, but now today there is some problem. Okay, so let us suppose 15th or 20th router, it broke down. So now the routing table, it will be disseminated. Okay, it will be shared. So router at India, it will know that there is some problem in this path. So let us suppose it will follow different route through Japan. It will go to USA. Okay, that is why it is known as routing, and that is why the device termed as router, because it finds out the best route to the destination. Okay, so this is what router does. Now here we use IP address, internet protocol address. There are other protocols as well, and protocols are nothing but they are the predefined set of rules. Okay, so this is internet protocol, that is why it is known IP. Now we have other protocols also we use here, that is ARP, address resolution protocol. Okay, and reverse address resolution protocol. What they does, they convert MAC address to IP address of that node, or to reverse means to IP address to MAC address. So there are multiple protocols, so many protocols, but I'm not going in depth. Okay, so here then we have the transport layer. Okay, now what will happen at the transport layer? The very first thing is, at transport layer we have uh, two protocols, TCP and UDP. Okay, so at this level, at transport layer, that packet, that data packet, which was known as a data frame in data link layer, in network layer, it was known as packet. Here, transport layer, it is termed as the segment. It is termed as segment. Okay. So now what will happen? Data packets, they are divided into different segments. Okay. So that is why you can see segmentation and reassembly. So data packet is divided into segments, and then those segments, they are delivered to the destination node. Now, at the destination end, they receive those packets. Okay. And after receiving those packets, each segment is having one sequence number. So if there is some escape or something like that, if packet 3, segment 3 uh, came first and segment 2 came later, so reassembling can be done easily because each segment is having a sequence number which is created by the sender computer or sender node. So at the destination end, it will be reassembled according to the sequence number. Okay, so at the sender end, segmentation will be done, and at the receiver end, reassembling will be done of those segments. Okay, now service point addressing, I'll tell you what is this. It is also known as port addressing, PORT, port addressing. Okay, so then we have segmentation and assembly, then connection control. Connection control. Now, what is this connection control? As I told you that at transport layer, we use two protocols. One is TCP and another one is UDP. Now, what is this TCP? uh, right here only. Okay. TCP. TCP is transmission control protocol, and UDP is user datagram protocol. Okay. Now, what these protocol TCP and UDP, what they do? So, what they do actually, these two protocols, TCP, which is transmission control protocol. Actually, TCP takes bit much more time than UDP. Now, why? Because in TCP, when a sender sends segments or data packets, the segments to the destination uh, node or host. So, firstly, the sender will establish a connection with the receiver to the destination node. Okay, the sender will firstly establish a connection. That is why it is also known as connection oriented protocol. Okay, firstly, it will establish a connection, and after that, once it has established the connection, then it will acknowledge. It will get acknowledgement from the receiver. Are you the same node to whom I'm going to sending the segments? So it will get the acknowledgement. And once the acknowledgement is received to to sender, to the node 1, then it will start start transmitting the segments. Okay. So that is why it is also known as three-way handshake. Okay. Three-way handshake, why? Because firstly, TCP protocol, the transport layer of the sender, it will send uh, it will establish a connection with the transport layer of the receiver. Then transport layer of the receiver, it will send acknowledgement that yes, I am the one. Okay, and then the transport layer using TCP protocol, transmission control protocol, it will send the data segment to the receiver, to the node 2. Okay, getting the point. So that is why it is called three-way handshake. So TCP, and once all the data segments are sent or transmitted, the connection will be aborted. Okay, the connection will be removed. Okay, so each time using TCP, when a sender sends something or segments to any destination, connection will be established. So that is why, due to this three-way handshake, it takes little bit more time than the UDP. But UDP don't do that. Okay, UDP do not establish any sort of connection, so it directly sends the segments. Okay, so that is why we have this connection control. Okay, so it will depend on which protocol the transport layer is using. Okay, so but this one TCP, if they are using TCP, it is reliable one, more reliable than UDP. Okay, then we have error control. Error control means, again, as we had in the data link layer, error control. So if there is any duplication or any lost segments are there, okay, or some skipped one, damaged one. So what will happen? Error control mechanism in this transport layer, it is done through retransmission of that segment. So that segment, because each segment will be having a sequence number, as I told you, when they create a segment through this segmentation, when they divide the whole data into segments, so each segment will be having a sequence number. If now 1 to 10 segments are transmitted to the receiver, to the destination node. Now, if segment number 5 not received, okay, at the when the receiver will reassemble those segments, and that system will find that I have 1, 2, 3, 4, 6 to 10, all the sequence number, all the segments with the sequence number, but I didn't receive that one, the fifth one. Okay, so the fifth segment, it will be retransmitted. So retransmission is the only error control here at the transport layer. Okay, so this is what happens now. Now see, it is very important to understand how this data link layer, network layer, and transport layer, how they work mutually. Okay, so might be you have seen many times that it is written TCP IP protocol. Might be you have heard that TCP and IP together. Sorry, TCP IP together. Okay. Now, what actually happens? Let me tell you. And we'll discuss this source point addressing, which is also known as port addressing. Now, let us suppose there is a network. Okay. So this is let us suppose this is graphic area network, GEHU network. Okay, and I'm taking another one as well. Now see, this is very important to understand how they work actually. And just a minute. Firstly, this one. Let me introduce a router as well at both the ends. Okay. And Okay. Just a minute. I'll take hardly 30 seconds more. Okay. Okay. So this one, the green one is our, this is our, these are our switches. Okay. So let me write as well. Switch. Okay. And so this is our switch one. And here as well, we have switch two. Now, and these red ones are, these are our routers. Okay. So now what will happen? As we have discussed that let us suppose this is our GEHU network, GEHU network. Okay. And this is our IIT Delhi network. IIT Delhi network. Okay. And these are the end nodes, means these are the systems. Now, this is how the network architecture it works. Okay. So let us suppose if this one, if you are sending from someone from IIT Delhi at this system, they are sending a mail to you. Okay. They are sending a mail to our network and they want to send from this system, from this system, they want to send it to the this system. Okay. So it is quite possible that okay, so they are sending a mail to you from Gmail. Okay. They are sending a mail through Gmail to you. Now, from here to here, from this node, from this system to this switch. Okay. So what address will work here? Here, it will work our MAC address. That is physical address. Okay. MAC address will work inside the network because switches know each and the MAC address of each and every node. Okay. Now, from this router, when this MAC address, it will from this node, uh, the data or the Gmail is sending something through Gmail. The one person is sending to this person at GEU network. Now, as they are different networks, so we'll be requiring IP address in between. And who deals with IP address? Routers. Okay. So now this router will find out uh, this router. So how to reach? There can be multiple routers in between. Multiple routers. Let us suppose this through this router they are connected to IIT Roorkee router, and then they came to GEHU network. Or there are some other ways they came to from this router and they came to the deemed university GEU router, and then they came to Graphicra Hill University router. So there are multiple ways. Okay, so it is as we have discussed the routing part. Okay, so this is all about routing. But when they will get connected, so the data which is Okay, the data which is transmitted over between the routers, that is known as packet. Okay, and this is the job of IP protocol. This is the job of IP protocol, internet protocol. Okay, to take that data to the data packet from one router to another. Now that data packet will come to here, this switch. Now this switch will find out this MAC address again. Okay, that to which system this mail should go. Okay, so MAC address will identify the system. Now at this system, the final system, there can be multiple programs open. Let us suppose the person is working on MS Word as well. Okay, they are open with the let us suppose Gmail as well. Okay, and the person is working on there's one application is also open. Let us suppose Media Player or VLC Media Player is also there. Now, what do you think? The mail, the Gmail which was sent to, you know, from this IIT Delhi's network, where it will go? Once IP address will take that packet to this destination router. Through this, it will go to the switch. Now, switch knows the MAC address. So through MAC address, it will reach here, and here the multiple programs are running. Multiple, even we can say on the same browser, 10 different websites are open. So the data packet will go directly to this Gmail part only, because it was sent from Gmail, so it will go to Gmail only. It will not go to Word. Okay, so it never happened that you send a mail to someone and that mail uh, uh, at the receiver's end it opens in Microsoft Word or in Microsoft Excel. It happens. Do you think it will happen? No, it will only open in Gmail. So that is why it is known as port addressing or service point addressing. Okay, okay, getting the point. So till here, TCP is also working, transmission control protocol, because it is making the connection, okay, with IP, using IP between routers. Okay, let us suppose you are at Delhi. One person is at Delhi, and this is the hotel. Okay, this is one hotel. So now what will happen when the person A, this is person A, and this is hotel, and in this room person B is there. Now person A wants to meet person B. Now what will happen? It will ask for firstly the address of this one, address of the gate of the hotel. Okay, so it will from Delhi, firstly it will come to Dehradun. Okay, so the bus which is bringing that person, that is IP, internet protocol. Now, so the person reached Dehradun with the help of IP protocol. Okay, the bus took him, or the road that took him. Now he reached, firstly it will ask for the, in Dehradun, it will ask for this gate, the address of this gate of the hotel. So the person will reach finally here. Now in this hotel, he will go to the reception. So this switch is working as a reception. Now he will ask for this address, where is that person residing, in which room is allotted to this person B. Now from reception, it will get that on the fourth floor in this room, this person is residing. So this is the MAC address, because within the hotel, inside the hotel, the room address, it is known by the reception, which is switch. Okay, so switch knows each and every MAC address. So it will tell you the room number, that is the MAC address, and finally the person A will reach this MAC address, this room address, and will meet person B. Okay, now it can also happen that in the same room there are 5 people, there are 5 or 4 people. Okay, they are within the same room. Okay, so finally to whom A has to meet? A has to meet the person B. Now this is our port addressing, this is our source addressing. service point addressing to finally to which application, to which person that person A wants to meet. Okay, so you got the idea that between two routers, IP will work from Delhi to Dehradun. This the road will work, or that bus will work, which will bring you to Dehradun. In Dehradun, you will find the address of this gate, that it is in Clement Town or wherever it is. And after that, once you reach that gate, you will ask for the reception. You will go to the reception. Reception is your switch, and switch knows each and everything about the network, the inside network. So it will tell you the MAC address, the name, the room number, and finally, when you enter the room, you saw 5 people, so which you have to meet. You will call the name of that person. So that is your port addressing. So this is how TCP/IP protocol they works together. Getting the point? So this is what we have discussed today, that transport layer, network layer. Okay, and their functionalities. We know what are the packets name, what protocols they use, which device they use. Okay, so I think this is enough for today. Go through